sorry for my background. I'm actually in San Francisco, so thank God for the internet. And I'm going to talk about our MCP server and a bit more about the details and what we did there. So my name is Mai. I'm the co-founder and CTO at HUD. We are building a runtime code sensor that runs in production and gathers context so that agents can write code that actually works in production. And of course, it's not just me. It's mostly this amazing group of people that's doing the real stuff. And I wanted to start with why. And MCP is such a big buzzword, and everyone needs one because it's like the cool new kid on the block. And I think that the first question that we asked ourselves was, do we really need that? And why would an MCP server contribute to our offering? And the short answer was because Cursor or any other coding agent is actually not connected to what's going on in reality. And MCP servers are a way to provide this context so that these agents work with that context in mind. And the same way that Nir just showed context 7 as a way to connect these agents to the documentation of those libraries, we are looking at the production code. And these agents have no idea which code is running a lot, which is not invoked at all, where time is spent, where errors are happening, and so on and so forth. And the ability to connect to that context via MCP allows the agents to make more concise choices, and other than just expect for the developer to know and to tell them about all of those. And I can give an example. For example, I can ask Cursor, users can't delete posts in production today. Why fix it? And in these cases, we won't get an answer of, well, I don't know, right? We will get some answers saying that there could be several reasons why users can't delete posts in production. Maybe it's a permission issue, maybe it's a database issue, maybe it's an error handling issue, but the most important part here is that there could be several reasons. But as smarter people already said, there can only be one. Something caused this issue in production, and a lot of things can theoretically happen. But when I am dealing with something that is hurting my customers, I want to know exactly what happened. And once the agent will have that context, it will be able to fix it. But right now, it's blind to what's actually going on in reality. And that is our why for building the MCP server. So let's talk about the topics and the agenda for today. I am not going to talk about what MCP is. I'm assuming that you already have that context in mind. But we're going to talk about how to actually build one from scratch, and the things that are not there yet, the challenges that we had along the way, and what could be done next. So when Anthropic released their Model Context Protocol blog in November, they actually also released a GitHub repository called the Model Context Protocol. You can see that it's actually not a part of the Anthropic repository. It was sort of their way to say, I'm not doing this just for me. I want to create a protocol that will sort of set the standard for the industry. And that really happened, where even OpenAI adopted it recently. And what we're seeing lower here is the Python SDK. There's also one for Node and other runtimes, which basically gives us the boilerplate template to start building our own model context protocols. It also has an LLM.txt file so that your LLMs can use the context to build the context protocol to give them more context, which is pretty nice and a little disturbing. So we actually have this boilerplate debugger as well. It's basically this binary for MCP where you can run your servers locally or even run them in developer mode, kind of like Flask and Django have their own infrastructure for that, or Nest.js if we're talking about Node. And if I run MCP dev and a path to my MCP server, I can actually run it locally, and I can use a tool called MCP Inspector. And this tool allows me to interact with my MCP server without having to go through the MCP client and handle the different paths that could happen. In this specific case, you can see that we now have a proxy server locally on port 3000, and I can see the different tools that I am exposing. and manually input different parameters to run them and see what the server requires and what I'm getting in response. I can also add some logs and stuff like that. And I think that was actually a brilliant move by Anthropic to not just talk about the protocol, but actually build those frameworks for us to be able to build on top of in such a convenient way. But let's talk about what actually happens there. So this is where it gets a little complicated. You import the fast MCP, and then you have to pick a name. It has to be a really, really good name. And then you basically initialize your server. And again, this is Python, but the syntax is quite similar for other runtimes. And once this happens, you have an MCP server in place. Of course, the MCP server can communicate via standard IO or SSE. The default is STD-IO with its pros and cons, just to be aware of. And once this happens, this is getting a little complicated, so stay tuned. We add a decorator called MCP tool or resource or whatever it is that we want to expose. We give it a name like get endpoint performance breakdown and a string that describes it. And that is basically it. The list of tools is now exposed. They are called in the names that we defined, and they are described in the strings that we defined. And this is basically how we set it up, which is pretty simple and elegant. And once this happens, I can actually look at this screen right here. That's the MCP inspector on my local computer. If I click on connect, I can actually connect to that server running locally. I can list the different tools that are exposed. I can see their names in the description, and I can also input specific parameters and run them to see the different reactions that will be provided to the different clients when called. So it's alive, which is pretty cool, and we were quite surprised on how easy it was to get going. And yet, it still doesn't connect to anything. It's just a local computer, local server running on my own computer on some local port and answering my questions. So maybe it wasn't that exciting after all. And on top of that, in our specific use case, there is another gap because production speaks in endpoints. We talk about a specific flow that's been hurt, like a sign up, or customers cannot change their email or something like that. On the other hand, what the agencies are local functions that are running statically on your computer, and the connection between them can be theoretically done by static code analysis, but it could get quite complex, especially in large code bases and in places where there are a lot of async context switches. We call this problem prod to code because basically the agent's context has a function level. As you can see here, I can tag a specific function, and then it has a name and the file path on my local computer in which it runs, and the lines that involve that specific function. And this is basically the atomic unit that the agent is used to. But production is not local, and the paths could be different, and there could be webpacking or transpilation or other processes that happen during the deployment. There could be bytecode manipulation if we're talking about Python. And maybe the branch that I'm on is not even the main branch, and the code that I'm looking at is not exactly identical to what's going on in production. So all of those issues can get to a point where we might not be able to match properly. And the MCP is stateless, and that's a really important thing to note, because if we're using some client, it could be Cloud Desktop or Cursor or Cloud Code or whatever, those have no context whatsoever that's passed along with the request. And therefore, for example, even if I know what's the open workspace, it won't be available for the MCP to understand. So how do we match production to what's going on in the code base? And basically what we did is that we have the runtime code sensor that runs in the client's production environments, and it sends over the function's identity, so unique describers depending on the runtime of that specific function's behavior without sending the code home, which was very important for us for security reasons. And we also link those metrics to the flows in which they run, meaning the endpoint or the event consumer. And all of those are stored so that the HUD MCP can get that function identity and match it locally to what is seen in the local machine of that user. So 3 different users can pull the repository on 3 different paths on different computers and still be able to see how they perform in production, even if they are in different lines or slightly different because of the deployment process. So basically, we have the top level service identification logic, which helps us match the application in production to the workspace in which we're looking at. And I'll ignore the more complex cases like monorepos, which are also quite challenging, but that could be subdirectories, or basically saying this application is represented in this workspace. And on top of that, we also have the function identity, which matches the function production to the function level that's local. For that, we mostly use AST parsing, abstract syntax tree, using tree sitter, which is GitHub's open source repository. I won't go too much into detail because that could be a 30-minute talk, just that. But the context here and the importance of this specific matching is that now we can actually speak the language of the client that we're working with, which is the local functions. So now we want them to kiss. It's not just about having the MCP. It's not just about speaking their language. We want to actually embed that into the process. And now it's going to get a little complicated. Take a deep breath. We go to cursor settings, and here we can actually add our cursor MCP servers. It's quite the same for the other editors as well. And once this happens, it could be either on a workspace level or globally, and the server can be accessible. In our specific case, we chose to use a binary so that the customers will not have to have a Docker or a Node server installed. But of course, it's a matter of choice. And what you can see right here is we utilize the environment variables to actually pass along the workspace key so that it could match to the relevant application in production, as I described earlier, which we found to be very, very useful, especially if you're running multiple MCP servers, because every different workspace you opened or every different instance of Claude Desktop actually runs its own MCP server. And in this way, they can differentiate and gather their results according to the context that they were provided. So we built an MCP server, we used the SDK, we connected it to Cursor, we got to the function level, and nothing happened. It just wasn't called, which was very surprising and a little disturbing. And I think that was another really important learning that we had, that it's not just about the content, it's also about the presentation. And how could it be that we have the server and it's available? And if I ask them specifically about HUD, it will call it, but it won't be a part of people's flow and their lives. And I think that's something that a lot of MCPs are missing today, in being able to embed themselves into the natural processes, because we're humans and we don't always remember exactly all the tools that we have in our hands for the best processes. And the same goes for the agents. So we actually changed a lot of our naming. So instead of saying, calling the tool get endpoint production context, we called it something in the likes of get endpoint error breakdown, which emphasizes the value. Because at the end of the day, this is not just an API. This is a tool that the agent can use in order to get something specific. For example, here, to get the endpoints and their root causes. And once this happens, it's actually a part of their flow and it understands the value of that specific tool. For example, if that tool was a calendar integration, I wouldn't want to call it get meeting by ID. I would want to call it get my meetings or get today's meetings. Things that make sense in terms of the flow and the value that these tools actually provide not just from a technical aspect, but also from a business logic perspective. And this was actually very, very powerful. And we thought that it won't be consistent and that it's hard to assess that. But at least on our experience, when you run a few dozens of tests, we actually saw very significant change for specific descriptions. Another thing you can do is to add rules, and these are the cursor rules, but again, different clients have their own set and their own words to say, things that help the agent understand what you want. And if we add a rule that says something like, when you're making a change, check the production context through HUD and make sure you're making the right change, this can actually contribute to being a part of that process again. So for example, if I want to check to change a specific endpoint to receive an optional parameter, now what we will see is that the first thing that happens is gathering the production context using MCP. And now, for example, we can see that this endpoint is heavily used and runs 358 million times a day. So of course, cursor will now behave differently. And after we gather the production context, we can also read the code. And now the agent really has all the context it needs in order to plan the feature, because it knows the production reality in which it runs and the actual code base together locally on the developer's computer. Another example we can look at is, now that we've made the change, can we deploy it to production? And now that we know the production reality, we know the usage statistics, we know the key function involved, we also know the changes we made, we can now assess the risk of that change before it's being merged to production. And look at the safety, see if we touched some business critical aspects to see if there are any ripples or potential impacted flows, and which monitoring we should go over. Let's look at another example. If a specific endpoint is failing and we want to know why, again, we will start by gathering the endpoint error breakdown and the production context, see that there's a specific function that's failing, gather its context as well, and see that it's actually a Mongo server selection error. And now, unlike what we saw in the beginning of the slide, cursor has all the context to be able to actually fix that issue because it knows where it came from. And it's not a bunch of theoretical reasons, it's a specific error that happens in a specific function and fails the endpoint. So we basically have the client and the resource. If it were a cookbook, it would say something like how to bake a cake or how to bake bread. But we still need the client to be able to say, if you're hungry, bake something. And that's where it would actually approach the cookbook and start reading the recipes. And now they kiss. A word on security. Security is still a thing. Don't run others people's code unattended, and mostly avoid the generic API keys that are shared across the organization. A part of what I'm trying to say is the MCP server building is not very complex, and in some cases you might be able to just build it on your own instead of taking that risk. Or if you choose to adopt some other technology, you can use the different marketplaces to see that you're using something that has the reputation. Know your why and why you're building that specific MCP server. What's your goal, and build around it. Make sure to match the context to the client's data schema. As we saw, for our case, it was functions. And as Toby, the Shopify CEO, said, he likes the term context engineering because we're trying to provide all the context that are needed for that specific task. Build the processes, not just the tools. I think for us, it was very, very critical so that these tools will actually be used in people's day-to-day lives. And that's how we measured ourselves. And in the bottom line, MCP is a really cool protocol. It's still just a protocol and it's brand new. So we are expecting some changes, but even if the name will change, context still matters. Better context gets the right outcome. And going that extra mile in setup and configuration and in the different interfaces can really help making sure that you make the most out of those. I don't know what the future holds, but maybe we're going to start some MCP religion and start praying to it. If you have any questions, thoughts that could be relevant either around HUD or anything else, feel free to reach out. And thank you.